Those Space People, a podcast series of casual cosmic conversations with people working on exciting space projects. Today we have Roxana Dumitru with us. Roxana is the COO and co founder at Paraloon. Paraloon is a new space startup for inflatable parabolic balloon structures for solar power in space and on Earth. Let's dive into our conversation with Roxana and know all about Paraloon and her incredible journey into space. Welcome to the podcast, Roxana.
Hi, thank you for having me today.
Roxana, what I find incredibly interesting is you have a background in architecture and then you eventually pursued research in space architecture. Can you talk about what led you to pursue this research?
Sure. Yeah, this is a very good question, and it's also a long story. I will try to make it as short as possible. So, everything started when I was 16. I made an exchange year in Germany because I wanted to learn German and was originally born in Romania and spent my first half of the life in Romania. Went to school in Bucharest, and after my exchange year, I went to university back to Germany. Studied at first architecture because I was always a creative person, but was also passionate by STEM, so science, technology, engineering, and mathematics. And that time, I considered that architecture and civil engineering were a good mix of everything. First of all, I obtained a bachelor and a master of science from the Technical University of Braunschweig. Graduated from the Faculty of Architecture and Civil Engineering. And then at the end, I did my master thesis in designing human habitat in an extreme environment. And this environment was a glacial lagoon in Iceland. And since that moment, I thought that I could actually continue these topics as a research project on another planet. So bringing this extreme environment from Iceland to another level. And here I am 5 years later doing a PhD in physics on this topic. It's mainly about radiation shielding on Moon and Mars. But I have to admit that the main motivation in really starting this research, because from that point of time it was just an idea. What about bringing this to another planet? The main motivation was actually the last ESA astronaut selection. I participated 2 years ago. I trained a lot for this selection, physical and cognitive training. Unfortunately, we were 23,000 candidates for 6 career astronaut spots. So this is a huge number for the number of spots. In the end, there were only 5 selected as full-time astronauts. And unfortunately, it was me in the corps. But this loss, so to say, led to an amazing initiative. And me and other fellow astronaut candidates have been working since then on a very nice project we really burn for and really believe in. We can see that the space economy is booming, the lunar economy is starting getting established. We are getting back on the moon and we're getting back to stay. There will be thousands of new space projects and thousands of space missions, which are going to bring significant benefits for all humanity on Earth and beyond. We are going to need trained people in space, and we are already training ourselves very hard for this amazing future. And we are even going to open this training very soon for everyone who is interested. I cannot say much more at this point about this project, but I promise to keep you posted.
Wow, that sounds very interesting. And it's probably the first time I've ever heard of a bunch of astronaut candidates starting a company or a project by themselves. That's pretty amazing. And I look forward to more details and more updates from your project. Hopefully, I
A
can
closed
sign up
door,
for some training at
a
your
closed
at
door
your
opens the
academy.
next one, right? Sorry, a closed door opens the next ones, right?
Ah, yeah, absolutely wonderful, very interesting. And yeah, that's a very interesting journey you've had from architecture to space architecture and then astronaut selection. And then you founded Paraloon. And can you talk about how you met your fellow co-founders, how you guys came up with the idea, and what was your inspiration to start Paraloon?
Boraloon is a startup I co founded with another 4 amazing guys, which are a true inspiration to me. right after the astronaut selection. So the astronaut selection was actually a game changer for me and a life changing experience. And also, two other co founders of Paraloon are also former astronaut candidates at ESA. My trainer at that time, Claudia Kessler, which I saw that she was also one of your guests in this podcast.
Yeah, and she also lives in Berlin.
Yeah, exactly. She offered me a scholarship from her organization, the Astronautin, for a course she was lecturing called Space Entrepreneurship. This course was organized by the European Institute of Innovation for Sustainability, which is set in Rome. But that course was that time online because it was during COVID and right after COVID, and they made it in cooperation with Airbus. I have to thank Claudia very much for this because this opportunity was very significant for me, and it led to an amazing thing, means which is Paraloon. And in this course, lectured by big names from the space industry, we got the challenge from Airbus to improve the technology or the business case for space-based solar power. So it was actually an idea contest. It was like lectures learning about how to make business in space, in the space industry, how to start and to contribute at this new space era. But of course, it was idea phase because this technology is very complex and it requires years of research and a lot of funding. So me and my group, we managed to improve the technology and also the business case. We had some nice ideas we presented at the end of the course, and we were encouraged by Airbus to make this project real. So we founded a startup called Paraloon, which comes actually from a parabolic balloon. In the last year, we won a few international awards from the European Space Agency to Entrepreneurship World Cup, where we reached the top 100 startups worldwide. And we started also the business incubation at the European Space Agency in Belgium this year, so 2023. And we also received the first European grants from the Belgian government in order to start working on our first prototype. So we more or less finished the pre seed rounds and we will start raising funds in the seed rounds soon.
Wonderful, wonderful. So, as a concept, space based solar power has been around for many years. There's been a lot of research papers written on it, a lot of people talked about it. However, it has not been realized so far. What do you think has changed in the recent times, both technically and in terms of having a business case? What changed in the recent times that makes this a viable business now?
So, as you said, space based solar power is actually a concept coming from NASA. It was never implemented as for that time the development was too expensive and we were not constrained by the lack of resources, by the reduction of the carbon dioxide emissions. We have to reach targets. And we were also not constrained by the geopolitical dependencies we have today. This is a very challenging concept, which is going to be a total revolution in our way of living and is going to be a door opener for markets we cannot even imagine. So all these reasons of the increasing of the electricity prices, geopolitical dependencies, decreasing of carbon dioxide, everything led to global cooperation right now in the development of space-based solar power plants in orbit, which are going to supply with 100% green energy, not only the Earth, but also other spacecraft, satellites, or even Moon and Mars, as it will be a continuous source of electricity, even in the shaded parts of the celestial bodies. If we think of the moon, yeah, a day night cycle is around 29 terrestrial days, and we have constant darkness and cold for continuously 14 days. So we need actually to think about other sources. So this is something which can be scaled on a galactic scale, so not only on Earth but also in space. The Paraloon is actually a concentrator solar system based on concentrator photovoltaics. It works as a lens or as a reflector and it concentrates the solar rays into a focal point. So you can imagine a sphere. That's why we said parabolic balloon, because it looks like a balloon, but it's definitely not a balloon because it's outside of the atmosphere. So the sphere is half transparent and half reflectant, takes the solar rays, concentrates them into a focal point, and in the center of this focal point, we have a satellite with thermophotovoltaic cells, which will collect the photonic as well as the thermal energy, and it converts it into electrical energy. Actually, it sounds simple. The paraloon itself is also ultra light and it's deployable, so it's very compact on the rocket. You can put a lot of them on one launch to launch a whole constellation of satellites if you want. On as a long-term goal, this will be our vision. And the difference to the common photovoltaic cells is the collection of thermal energy. So we don't take only the light, but we take also the heat. So the Paraloon is actually, with this add-on, 2.7 times more efficient than the common photovoltaic technology regarding to the math. Of course, we're going to test it. The testings didn't take place yet. This is what we plan for the next year. So we are using thermophotovoltaic cells, or a combination between photovoltaics and thermoelectric generators. We also initiated the patenting process for this and submitted the patent application. You also asked me about the business case. Yeah, we have a three-step approach, which makes it realistic, especially for the next years where the beaming from the orbit to the Earth is not working yet. At first, we aim to sell the concentrator system, which can be used by other companies for pretty everything as a part, so we can work as a part supplier. We can sell also the deployable structures, which can be used also for communication purpose, like an antenna. Like you can make small things, pack them on the rocket, and they inflate or they deploy in orbit for whatever purposes. Then our second step would be to sell or to rent the full functionable satellite, which means the concentrator plus the CubeSat attached with the beaming system. We're gonna not gonna do this beaming on ourselves because we want to cooperate for the beaming with other startups which are developing this technology. So we're gonna do just the collecting of the energy on the satellite. And our long-term goal and big vision, as I said, is to have a constellation of satellites in orbit, in Earth and on the moon, and hopefully also on the Mars. So we think for now, in 40 years, they're like Starlink, but for energy production.
And how does this system look exactly? And you also mentioned there's, of course, there's going to be like the satellite at the center of this parabolic balloon. And how is this satellite different from, I don't know, regular satellite?
It's very light and it's deployable. It's like a sphere. I mentioned at the beginning that it looks like a balloon, which is half transparent, half reflectant. Solar rays are gonna get through the transparent side. They're gonna reflect in the reflectant polymer because it's gonna be a polymer, and all the rays are gonna be concentrated in this focal point where we have an attached CubeSat with the sensors on it. So we're gonna use technology which works at high temperatures in vacuum. So there's actually a selective emitter technology. So actually, it's a big balloon. How big we have to test depends on the quantity of energy which is needed, yeah, in order to beam it on a later point of time. And all the conversion takes place on the attached CubeSat. There are a lot of technical challenges, like finding the right orbit. For example, in the low Earth orbit, the paraloons will be way too quick to communicate with them properly and also to control them from the ground control. And we also want to avoid a collision with a space station. The ultimate goal is the positioning in the geostationary orbit, but of course we have the issue with the beaming because the beaming from that distance will be very challenging. This is also what the ESA Solaris program is targeting. So from my point of view, the main challenges are the positioning in the right orbit, so communication issues, not losing the satellites in the Van Allen belts, because this is also a point, the controlled beaming through electromagnetic waves. We are, as I said, we're not going to do the beaming ourselves. The frequency, of course, we have to find the right frequency the Earth receiving system, which must be low enough in order not to disturb flora and fauna. Of course, we're going to have losses up there in orbit on the paraloon itself, and losses through the atmosphere. This problem we're not going to have on the moon, or we're going to have less of this problem. And of course, yeah, we are challenged also by space debris. We will find out more in the testing period, hopefully next year. And after the registration of the patent, which we already submitted, we would be able also to show some technical drawings and simulations of the satellite. So for now, you can imagine like a kind of a big balloon, which is actually a lens. It's not a balloon, it's a lens with a small satellite attached on it. So the difference to the classical satellites is we don't have these huge wings full of solar panels, which are very heavy. We have like a small bag, like a backpack, kite surfing. Like you have a small backpack, and then you inflate the kite, and then it's gonna be a huge thing, which is gonna help you go over the water. So it's gonna be a similar thing. So we're gonna have a small bounding box at launch.
Okay, wow. You've painted a very clear picture, and that looks straight out of science fiction. But today's science fiction is tomorrow's reality. So I'm super looking forward to tomorrow's reality. Yeah, next year, yeah, absolutely. I'm going to look forward to a lot of these balloons. Hopefully, with a telescope, I can try to spot some of them. I was also very curious about the whole space debris, but again, with the whole the space ecosystem getting more and more regulated, I believe there would be a better way of dealing with space debris in future than the one we have right now.
Space debris is our biggest enemy in the 21st century. Biggest enemy of this century, right? For all the spacecrafts and also from the astronauts, what are we going to do with them? Of course, there are a lot of concepts right now regarding space debris, how to collect, how to recycle, what to do with them. Regarding Paraloon, we're going to have the orbiting system in the satellite. So according to the international standards, every satellite should have a so-called end of life maneuver. And depending on the orbit, we're gonna position ourselves. So if it's Leo, one of the Meos, or the Geo, we're gonna find out through testing which is the optimal for us, for our shape, and for our quantity of energy we want to collect and to beam. In the Geo, we can push out to a graveyard orbit, or for the Leo, there will be a deorbiting burn. Yeah, like the ISS. We are gonna see the funeral of the ISS in the next time with the deorbiting burn. So we are developing also solutions of self-patching in case of damage in the paraloon. So of course we have two cases of debris. One, if the paraloon itself is going to become a debris, we have to burn it, okay, or to put it in the graveyard orbit. Or if we are going to get damaged by a micrometeorite or by a piece of from another satellite which is orbiting. These are things which might happen, and they're super realistic that something like this would happen sooner or later. So we need to develop a patching system in case of damage, like self-detection and self-patching. But fortunately, if we have minor holes in the system, we are not gonna be very disadvantaged, because fortunately in space there is radiation hardening, which keeps the paraloon in shape. So the shape will remain because it's hard. So we will have a bit of heat losses, but as long as the holes are not super big, what means super big, depending on the proportions, but we can still manage to produce electricity, but we will have more losses. So yeah, self-patching systems are also going to be developed, and they're a great topic.
Okay, so interesting. Have you also looked into how it would impact astronomy, as in astronomical observations done using terrestrial telescopes?
Not yet, but of course they're gonna be seen somehow. They're gonna be more or less shiny from time to time, or in the night we can see also the Starlink in the night constellation when it's passing by. So it's gonna be probably something similar, depending also on the on the size. Yeah, we hope we're not gonna have reflectors. So this is the kind of thing we want to avoid. So we won't have like huge suns or huge stars looking like huge stars, but we you will still see some white shiny dots.
Okay, that's very interesting. I will look forward to more details when you file the patent next year. That would be very interesting to read.
Sure, I will be more than glad to show you more and explain more about it, because during the R&D phase we'll probably find out more issues, or we're going to invent some more parts we don't know right now, because of course we have simulation and we're going to build the simulation with the first fundings we got. But once you're in the testing phase and once you're launching and seeing how the Paraloon behaves in space, then we're still going to change design or some components of it. So it's going to be a very exciting period for us, and I'm very happy to start working on this prototype.
Absolutely, and for the space community as well. And so, the first test satellite or the first test mission, how big do you think it's going to be? How big is the parabolic balloon going to be? How much power do you think it will be able to handle? Just ballpark figures, numbers.
We're, we want to do three sizes. So the very first one, which is going to be cheaper, of course, is going to be in small scale on Earth in order to test the beaming on Earth. I saw a beaming on 100 meters at Airbus, for example, last year. So on short distance, which size we have to figure out. So it has to match in a building, of course, in a hangar, and not to be too big. The second one is going to be deployable. So we can go for a bigger size to test in space to see how much, and there we're going to find the right size, like how much energy we can really produce in space, which is the right size. And the third one is going to be a 1-to-1 scale. So for 2.7 kilowatt, it would have a diameter of 80 meters. So at the end, they're going to be pretty big, but probably we won't need that amount of energy. So it's going to be related to the demand, and it's going to be related to the number of satellites we're launching. So we want to be as small as possible and as effective as possible. So yeah, we will see the right dimensions soon.
And 2.7 kilowatts is after the conversion, is what reaches the ground or is what it's captured in orbit?
What reaches the ground? Yes. So this is actually 2.7 times more than the classical solar panels up there. So more effective. Yeah, lighter, more effective. At the end, the production is going to be also cheaper, but of course the R&D until there is going to cost something.
And especially with solar cells are going up in cost, right? By day, I mean, 10 years ago it wasn't as much, but now one of the most expensive components are the solar cells. And yeah, maybe this sounds very promising.
The problem with solar cells is that they're heavy. So they're also, you have higher launching costs.
Yeah, absolutely. Yes, that is very true. Maybe can you paint a picture to me when the whole space based solar power becomes a more of a mature technology? I don't know, in maybe 5 years or 10 years or 15 years. How do you think the whole space ecosystem is going to be? How do you think all satellites will no longer need to be launched with solar cells? They can directly draw it from a paraloon constellation, or how do you think it's going to look?
Exactly, this is the plan. So we aim to be able to beam on other satellites, on space stations like the ISS or the next private space stations, which are going to be launched by Axiom, Blue Origin, and other private companies, and also on the habitats on the moon. We also have some ideas of cooperations with the company which is making lunar rovers to beam this energy on the rovers. Of course, in motion is going to be a more challenging thing. So, what first of all, we have to manage to send the energy on a static point, like on a receiving system, on an antenna. The capturing is not the maintaining of the energy in these antennas is not necessary because we can beam anytime in another place where this energy is needed. Big logistics facilities to capture the energy and store it there is not going to be needed. Also, the I think the aerospace industry and the airplanes are going to improve a lot because space-based solar power was also re-brought to life as a concept also for the airplanes. So the airplanes, the future airplanes, can get rid of the kerosene and work with hydrogen motors. So in order to produce that much hydrogen, we need huge amount of green energy, because right now we are not able to produce that much green energy on earth in order to have that much hydrolysis. Of course, there are also other nanotechnologies more effective than the hydrolysis, but you need like huge amounts of hydrogen to have the airplanes work with hydrogen. The big picture, actually, the big goal is also to beam on airplanes directly, but this is, yeah, it's not going to happen very soon. But it would be nice if we could live in this life, this moment where where all the mobility is actually completely free of CO2 emissions.
Would it be easier to start with beaming solar power to satellites first, or objects in space, than on Earth? Because the beaming distance is much lower if you're just sending it from a paraloon satellite to a satellite in orbit, right?
Of course, yeah, we have less distance, we have less losses through the atmosphere. Maybe we don't have the atmosphere yet if we are high enough. This is one of the first things we're gonna test, like beaming on shorter distances, which is on satellites or space stations, before having them come to Earth on an Earth receiving segment.
And to receive the space based solar power, how do you design a satellite? Can it just have a plug in module, or does the entire satellite have to be redesigned with a different material? I know it's a little bit ahead of in your plan, but have you thought about that?
We thought about that. We can imagine that it's gonna be like a kind of antenna which can be attached to every satellite or to every station. As a first step, we're not going to make this antenna ourselves, but there are also other startups working already on this receiving segment, which is going to have different dimensions for different purposes depending on the quantity of electricity needed. So yeah, it's going to be actually a Wi-Fi electricity.
Wireless charging. Yeah, of course. I can imagine that.
The first phones also had an antenna, and now they don't have a visible one anymore.
Yeah, absolutely. Yeah, yeah.
Let's see where this leads.
We've spoken a lot about Paraloon and a lot about this space based solar power. Maybe let's talk a little bit non technical aspects. Roxana, you are from Romania and you studied quite a lot of your education you've done in Germany. So, how do you see the cultural differences from in Romania versus Germany? Because I come from India and I see it's very different from Germany. It's a very different culture. It's a very different way of approaching a problem. Even professionally, it's because of the cultural difference, it's quite different. And I have a few friends who are from Romania, from Bucharest. And culturally, I find a lot of similarities between Romania and India. So I'm very curious how you find Germany.
I have been spending the half of my life in Germany, and I consider myself half German, half Romanian. I also own both citizenships and speak both languages as my mother tongue. I try to get the best from both cultures. They are both European cultures, and I don't consider them very different. So it's not like India and Germany, where of course you have more distance and you have totally different food and more different habits. So between Germany and Romania, of course, you have some regional differences also regarding the food, of course, another language, maybe in the habits, some minor differences, but to be honest, it's not that different. That the differences are not that big. It's still EU, and if you go from a country to another, you don't really notice. Yeah, only you hear the people looking maybe a bit different, like having a bit of other, yeah, small things in the faces, like maybe different hair color, but well, we live in a global. When you live in the globalization, we're starting, all of us, to look similar and to behave similar. And from my point of view, there are not that many differences. So then this is something I like. I like different cultures. I made an internship in China many years ago, like eight years ago, and that was a big difference for me. And not only regarding the language, the food. I love Chinese food. I love Asian food. I like eating in general, so I like all the foods from everywhere. But also in the behavior, like the way you work, the way you behave at work, the way you address people, it was way more different than between Germany and Romania. Because this is, for me, for example, in the working culture, unfortunately, I didn't have the opportunity yet to work in Romania, so I cannot tell a lot of things about this, but the way you address people is pretty similar. The way you salute is pretty similar. So the way you behave when you're eating in a restaurant is similar.
Completely agree with you. The world is becoming more of a global village, and there are fewer and fewer differences nowadays between people, especially if you're an urban dweller, someone living in a city, then it's more or less the same. It's the same Starbucks, the same McDonald's across the world.
Exactly. The
and
big corporations are everywhere and they have their headquarter everywhere. So
and especially if someone is in the space bubble, then it's a much much smaller cultural differences or any sort of differences. Yeah, space is a very small bubble.
it's like a family.
Totally. And I meet my fellow space enthusiasts and my friends in the industry more often. I see them more often than I see my family.
Everyone was knows everyone in the space industry, and yeah, it doesn't matter where you come from, what is your mother tongue, and this is something I really love and I really appreciate. And you learn from other cultures too, and get the best out of everything. And only this is the only way we can make the world better, a better place, also for the next generations.
Absolutely. Yeah. And speaking of the space being a very small bubble, you came from a background in architecture, right? It's not a STEM field. Did you face any challenges in getting into the whole space jargon?
Not yet, because I come actually from a STEM background. I'm also a civil engineer, and my PhD I do it's in physics. So until now, I didn't face that many differences. Also, especially because I'm not working in a space company right now, or at least not in the last years. I came from a construction background, and I've been working at Mercedes Benz as a project manager at first, and then a program manager and a team lead on construction projects. So everything is very technical. And until now, I didn't face that many issues. And I try to learn as much as I can and to improve myself continuously and extend my knowledge in STEM, especially in physics. If we're looking at Paraloon, is so much thermodynamics in it, and so much physics, so much astronomy also. That's why I try to learn as much as I can. And also through the astronaut selection, I learned a lot, and I did a lot of practice and in maths and physics and trying to be quick. And yeah, and also as a, if you're training for space missions, you have to have a lot of knowledge in STEM. So maybe, yeah, I didn't study this from the beginning. Yeah, I studied architecture at the beginning, but I had a more technical background. So it was a technical university, and my degrees are also in science. But I try to improve myself and learn as much as I can, because this is what we're doing actually until the end. You don't know enough things. We are not working as an AI yet, at least not yet. So we have to keep on learning and improving ourselves.
So, can we talk about your other co founders at Padaloon? What kind of backgrounds do they come from?
So some of them come from the space industry, some of them not. As I said, two of them were also former ESA astronaut candidates. We have PhDs around us. We have researchers who've been working at ESA and CERN and learned a lot how to do R&D. Our C worked also on the photovoltaic system of the ExoMars. Yeah, some of us work in the satellite business, one of us, and another one right now he's living in the US, but he's Polish, and he's working in the energy sector. So we have a bit of everything. Like me, like me myself, I have experience in management. I did a lot of project management, program management. So I'm like the one more in charge with the organization of the project and like getting funds, pitching, etc., managing the internal processes, defining internal processes. Two of them are a lot in charge with the tech, the development of the tech, because they're very skilled and very experienced in this kind of stuff. One knows a lot about the energy sector, and the other one knows how to make polymer structures because he was a researcher in the polymer field and has his doctorate degree, his doctorate in obtained in Stuttgart in doing this. And also regarding the financial part, he has a lot of experience in that because of his background, and also co-founded another startup in the past. So we have a bit of everything between us, and we try to learn as much as we can, and also to see in the future where are we actually lacking of expertise in order to outsource it and to take as much support as we can, especially from ESA, because now that we started already the incubation at ESA, we can get a lot of support and ask for advice or to outsource in an area we don't have enough expertise yet. And we all met
Wow.
in this course, which was amazing. Yeah, I can recommend to everyone. I think they're making this every year.
That's pretty amazing. I have really great hopes for Paralone, and I'm sure everything would turn out very, very good for you guys.
Thank you so much. We are doing our best, and there will be a lot of challenges, especially technical challenges and also funding challenges, because the prototypes, of course, they require some funding. And I think the best things in life happen when you don't plan them. So we didn't even plan to make a startup. It just happened organically, and we found each other. Like, we were mixed already regarding to our backgrounds. We were mixed in groups, and this was the group. And as I said, we found each other without looking for each other.
Wonderful. And I also think the tech part of space is not that hard. If we throw enough money and enough time at anything, it's very easy to come up with a technology solution. But I would say the biggest challenges in space is actually the regulatory aspects and the business aspects more than the technology. And with people coming from different backgrounds and with experience in different industries, more than backgrounds, people with experience in different industries bring a sort of fresh perspectives to solving problems in space. Yeah, that's something to look forward to.
Yeah, we don't have to reinvent the wheel. There's a lot of things up there already, and there are a lot of smart people who invented a lot of things. We just have to mix what we have to make smart enough and put it in a working yeah, construction or satellite. Of course, we're going to have some small innovations ourselves, but the big things like the whole concept of space-based solar power, yeah, we didn't invent it.
Yeah, essentially it's like Legos, right? Like you said, no point reinventing the wheel. We already have all the building blocks. All we need are good architects and civil engineers to
Yeah.
take it forward.
Yeah. And I think space architecture is something which is going to be more and more important in the future, especially when we're going to build the lunar habitats. Okay, the first modules we're sending are going to be made on Earth, and we're launching them. India also makes a great job in this. And we have to redesign all the constructions and the infrastructure to rethink everything we're gonna put on the Mars, because when architecture actually follows the rules of physics. What we're doing here, it follows the rules of physics regarding to this type of environment, to this gravity, to this kind of atmosphere. And the buildings are going to look totally different on the moon, because we have a different environment. We need air ventilation, we need like pressurized habitats, we need life supporting systems. So we need actually professionals from all the fields, bring them together in order to create such habitats which are gonna make life on moon and Mars possible. Because with the right technologies, I believe that you can live everywhere in a different way. You have to adapt. But we humans as a species, we are very adaptable, and we are known for our adaptability. And we will see which are our limits.
Yeah, absolutely. I completely agree with you. And as a technology, I believe space architecture is also very scalable. It's very transferable, right? For example, you mentioned that your foray into space architecture came from building structures in extremely cold environments. And you can extend the same thing to building these architectures for in times of natural calamities. For example, if there are floods, how do you quickly deploy a habitable space which is cheap and accessible? So yeah, the space architecture is a very spin-offable, I don't know if that's a word.
Probably, yes. That sounds very good.
Yeah, so that's a very spin-offable technology, and I wish more people thought about it. I find it more and more interesting and enthralling, and I hope more people from different backgrounds start thinking in this direction, start making efforts in this direction. That would be interesting. And speaking of people from different backgrounds, what kind of career opportunities do you see around you? You do have a kind of mixed background: architecture, space architecture, physics, and all the astronaut training related skills. Amongst all these, what kind of career opportunities do you see, and what is your advice to young professionals who want to embark on a journey similar to you?
Wow, that's a very good question. Career opportunities. I think the space industry definitely has a lot of career opportunities. And I think through the private astronaut training and through the private space stations, which are going to be launched in the next years in orbit, and through the future lunar habitats we are already planning and already launching, and thinking also about Gateway, thinking about Orion. There's a lot of potential out there, and I think there are gonna be new career fields which are gonna get born. I really think that there are gonna be door open doors and new space for new markets which we don't even think about now in the future. As an advice, if I could give an advice to the young professionals starting their career or starting studying something, I think every area you do well and you learn well has potential to grow and has potential to develop and has potential to be implemented in innovative topics and innovative projects. Yeah, for example, think of agriculture. Yeah, agriculture, we're gonna need these kind of people on space stations. We're gonna need them on the moon, also on the Earth, because we don't have, like, our resources are not infinite, and every space applications we are working on, they have applicability on Earth, and they make life better on Earth too. And of course they open horizons to expand also on in other areas, also to make us live in extreme environments. So I think, yeah, every area one is passionate about, if you are passionate enough and you want to make the best out of it, you can always find innovation in areas and find applicabilities on Earth and beyond Earth.
Wow, I love the way you worded it. Thanks for that insight. And we've had a very long conversation about all the incredible things that you've done, Roxana, about Paraloon, about how you see the future of space based solar power. Thank you so much for your time, and thank you so much for sharing these incredible insights. I'm sure the listeners will find it very interesting, and I really hope for more people foraying into space architecture as a career inspired by you. So, thank you so much for all that.
Thank you, too. It was a pleasure.